The empirical rule in Algebra 2. The empirical rule is also known as the 68, 95, 99.7 rule. This is usually what we refer to it as in Algebra 2, but it is the same thing as the empirical rule. So what this does is that it basically states that 99.7% of the data will fall between plus or minus 3 standard deviations. Remember, standard deviation is that O with a hat. So if we break it down even further, since 68 comes first, that means 68% of the data will fall within plus or minus 1 standard deviation from the mean. And then 95% of the data will fall between plus or minus 2 standard deviations from the mean. And 99.7% will fall within plus or minus 3 standard deviations from the mean. And this rule only does plus or minus 3 standard deviations. That's the highest we will go to. This rule also looks at a picture of what is called a normal curve. And whenever something is a normal curve or normally distributed, you will see this picture. And so we're going to label it. In the middle, it's always your mean. And remember, the mean, we use that weird U to describe it. And then if we go to the right, that is adding 1 standard deviation from the mean. If we go another spot, that would be adding 2 standard deviations from the mean, and then adding 3 standard deviations from the mean. And if we go the other way, it would be subtracting 1 standard deviation from the mean, subtracting 2 standard deviations, subtracting 3 standard deviations. And so what our rule tells us is that between -1 standard deviation and +1 standard deviation, 68% of our data is there. And from -2 standard deviations all the way up to 2 standard deviations, 95% of the data is there. And then from -3 standard deviations up to +3 standard deviations, you get 99.7% of the data. So let's actually look at an example. So with example 1, on the last Algebra 2 test, students' scores represented a normal curve. So that right there means I'm going to be using my 68, 95, 99.7. After analyzing the test results, we found that we have a mean of 80% and a standard deviation of 5. So if we were to label just one of these graphs, our mean always goes in the middle. So in this case, it's 80. And then if we were to add a standard deviation, my standard deviation is 5, so I would say 80 plus 5 would give me 85. And then if I add another standard deviation, that would give me 90, and then 95. And if we were to subtract a standard deviation, it would be 75, subtract another would be 70, subtract another would be 65. So now I have my normal distribution labeled. My question is, 68% of the students scored between what and what? Well, I know 68% is between -1 standard deviation and +1 standard deviation. So I'm looking at all of this data. And that is between the number 75 and 85. So those are the numbers I will fill in here. Now let's do it again. So we can use the same numbers that I wrote over here in green, so I'm just going to relabel it. This question asks 95% of the data, or 95% of the students scored between what and what? Well, I know from my empirical rule that 95 is 2 standard deviations. So we're going from -2 to +2. So I'm looking at all of this data. And that falls between the numbers 70 and 90. Then we can do it again. I'm going to just copy over my numbers. And this question is asking 99.7%, which I just learned goes from -3 to +3 standard deviations, which is almost all of the curve. And those numbers are 65 to 95. So that is an example of the empirical rule, which is our 68, 95, 99.7% rule. Now, if we flip the page, we're going to break down our empirical rule even more. So we're going to label this, which our mean is in the middle. We go +1 standard deviation, +2 standard deviations, +3 standard deviations. We subtract 1 standard deviation, subtract 2 standard deviations, subtract 3 standard deviations, just like before. Now, don't write this part down because I'm going to end up erasing it. But we learned from -1 to +1 was 68%. But I just want to know what the mean to +1 is. So what I'm going to do is I'm going to take 68 and then divide it in 2. So if I do 68 divided by 2, I will get 34, which means each of these marks, each of these sections, are worth 34%, because I can still go from -1 to +1 and get 68. Now if I go, again, do not copy this part down, but if I go from -2 to +2, I get 95%. But if I just cut that in half, that becomes, well, we find out with our calculator, so we can go 95 divided by 2, which gives us 47.5. So the purple is 47.5, but I already know that this section is 34%. So if I take 34% away, I get the number I want. So now we have 47.5, and I want to subtract 34, which will give me 13.5. So that means each section after the mean is worth 13.5%. And then we have the same on the other side, 13.5%. Then we're going to do the same thing with our 99.7. So the whole thing here is 99.7. But if I cut that in half, I need to figure out that number. I'm going to go to my calculator. I'm going to take 99.7 divided by 2. That gives me 49.85. Then I want to subtract the things I know. So I'm going to subtract 34, and I'm going to subtract 13.5. And I get 2.35. So that means that each section after the 13.5 is worth 2.35%. So this covers 99.7% of our data, but we still have these outsides that are left. So what we have to do is we have to take 100% of our data, subtract the 99.7 that we just broke down. That leaves us with 0.3. Then to find these outsides, we're going to take 0.3 and divide it by 2, which leaves us with 0.15. And these are numbers that you will want to memorize. They are not given to you. You're expected to know how to break them down. So it's easy to just remember 34, 13.5, 2.35, 0.15, because it's the same on the other side. So now let's go back to an example using what we just broke down. So if we're still talking about our Algebra 2 test with our mean of 80 and our standard deviation of 5, we have the graph labeled for you with your mean in the middle, and then we are adding standard deviations and subtracting standard deviations. So question A asks, what percentage of students scored between an 85 and 90? So between the 85 and 90 is this section. So it's between my first standard deviation and my second standard deviation. And now if I look back up at the top, between my first and second, I got the number 13.5. So that is my answer for part A. Now, part B. What percentage of students scored below a 75? So 75 is one standard deviation below, and I want everything below it. That means I need to take my 2.35, oh, no, I'm sorry. We need to take our 13.5, that was between the 1 and 2, add the 2.35, which is between the 2 and 3, and then add that 0.15 that comes after it, which will give us 16%. Now part C, what percentage of students scored higher than 85? So 85 is one above, and I want everything higher, which again, I need to take my 13.5, add the 2.35, and add the 0.15, which gives me 16%. All right, I'm actually going to skip example 2 for this video. You can come see me and I can walk you through it, but you don't really need it for the overall purpose of this video. So let's go to the next page. We do want to talk about breaking down our empirical rule some more. So Keeter's Cereal Distribution Center has determined that the weekly order from Clarkin's Market Store for Suds Honey Toasted Oats is normally distributed with a mean of 800 boxes, so there's my mean, and my standard deviation of 75 boxes. So the first thing I want to do is label my graph. Remember, the mean goes in the middle, so we're going to put 800 in the middle, and then 875 with the standard deviation, 950, 1025, and then we subtract going the other way, so 725, 650, and 575. Now let's go to answer our questions. So for part A, what percentage of stores ordered fewer than 650 boxes? 650 was 2 standard deviations below, so I want everything below that. So first I'm going to shade it in, and then I'm going to add my 2.35 plus my 0.15, and I get 2.5% as my answer. Part B says what percentage of stores ordered more than 875 boxes. So 875 was 1 standard deviation above, and I want everything more than that. So I'm going to shade in my graph, and then I can also reference up at the top. Now, at the top, you can also fill in that each of these are worth 34%, And then after the 34 comes 13.5%. After 13.5 was 2.35%. And then after the 2.35 was 0.15%. So those are the numbers I used for A. I'm going to use those same numbers to figure out B. So I started at the 1 standard deviation above, so here, and then I want everything after it. So that means I need to add 13.5 plus 2.35 plus 0.15. And when I do that, I get 16%. You guys can pause the video and try C, D, E, and F on your own. I am going to continue to work through them, just at a bit faster pace. So what percentage of stores ordered less than 875? So again, 875 was one above, and I want everything less than that. So everything less than that included 13.5 plus 34 plus 34 plus 13.5 plus 2.35 plus 0.15. So if I add all that up in my calculator, I have 13.5 plus 34 plus 34 plus 13.5 plus 2.35 plus 0.15. Let me hit enter, and you get 97.5%. Part D, we go from 725. So 725 is one below, and we're only going up to 950. And 950 was two above. So I want this section, which is 34 plus 34 plus 13.5. So we can go 34 plus 34 plus 13.5, 81.5%. And then E, what percentage of stores ordered between 650 and 800? 650 is two below, and then 800 is my mean. So all I need to add here is 13.5 plus 34. So again, I can use my calculator, 13.5 plus 34, 47.5%. And make sure you are shading in your graph as well. Then F, what percentage of stores order between 725 and 875? 725 is one below, 825 is one above. Now notice it's one standard deviation to one standard deviation, which is my 68% rule. But if you didn't recognize that, you could still get 34 plus 34, and it'll give you the same thing. So that's an overview with the empirical rule. Make sure to stop in and see me if you have questions.